Hey guys, we Kool-Aid here. And we'll give you a video. Hey, we're going to talk about this solar storm that's going on right now. I got you over at Space Weather. First thing I want to say though, guys, anybody down in Florida, obviously you guys know, talking about the hurricane and all that. Anybody on the West Coast, or not the West Coast, the East Coast, should really be paying attention. All up and down the coast. Okay? Because they've changed the forecast of this hurricane so many times already, it's crazy. Okay, the models went from here to there, swing, and that's why they give you ranges. All right, because it's kind of their out of saying, "Hey, I was wrong." But it is a very hard thing to try to pinpoint, especially when we start talking about weather manipulation and all those subjects that come into play here. Because I was talking to Scott yesterday, and we were talking about how they do this. What they do is they use microwaves. They heat the air up, cause high pressure, and it helps steer these things. We would be foolish to think that our country is the only, and I'm talking about the United States, the only country around here that has that kind of a technology. It's not true, okay? Um, so, and they do come out and say, yes, we have this technology. They don't typically try to hide that much. They're not going to go out there and put it on blast, but it's there if you guys go look. It's something I don't talk about much because it definitely is something out of my wheelhouse. I don't know much about it. I do know that the microwave thing. Obviously, if you guys even just take that back to the microwave you have in your house, it heats things up. Okay, so we all know that temperature really has a lot to do with how these hurricanes, the strength of them, how they get steered, all that stuff comes into play. But with that being said, this thing is all over the place. Right now, the last I looked, they're looking at this thing going up the East Coast, not even making landfall, for a while. So I just wanted to point that out because that, in my opinion, and me and Scott were talking about this morning, that could be very, very bad. If it keeps any kind of strength, just hugging the coast, it would really extreme. It would affect so many more people than if it just came on land and died out. That's kind of what I'm saying. So if it actually does just hug the coast and go up the way that they're talking about right now, it's going to affect so many more people in such a drastic way. That's why, when we talk about living on the coast and stuff, that's why even if you're not talking about the Planet X subject, just having life in general, being prepared for stuff, that's what we're talking about when we say prepare. Okay, we're not talking about necessarily the big, TF stuff. Okay, I've never been a good proponent of that. I always say prepare for, a general emergency. That way you can still use what you have, and if nothing ever happens. Okay, so but anyway, what we're going to talk about here, guys, we got a G2 level storm. Okay. I think I've seen it up to a G3 this year. We haven't seen much because obviously we're in a solar minimum. But if you see the wind speed here, 794, that's very, very elevated. Okay, and I'll take you guys over to a converter here in a minute and show you what that is in miles per hour. But if you look at the KP, which is just a storm level, you could think of it like a thunderstorm level warning. Obviously, the higher it goes, the worse that it is. I'm going to talk about this specific spot right here, okay? Because we had a little elevation and then it spiked up to storm level, okay? Now, I talked about this yesterday, and when I showed you guys the graph and the chart and stuff, it looked as if this thing got here 24 hours too soon than what they were predicting. All right, well, it really got here probably about 12 hours too soon because this is actually when it got here. And I'll explain here in a second. But as we're looking at this, if you look at this chart here, this is the ACE, and I show you guys this a lot. You got the yellow one. Okay, that's the speed. The density's up there. Guys, I can't stress enough how important it is to look here first. Okay, you don't know what units you're looking at unless you look there because they change that. When things get like way high, they have to change the values over here because if they didn't, the chart itself would be huge. This is what it would look like, okay? It would have lines, and this is just the yellow, is what I'm talking about. So they have to do that. They can't do it any different, or you'd never be able to see the whole graph. Typically, this starts at about 200, and then it'll show up to 400. Obviously, they're showing up to 1,000 because the wind speed's getting up there, okay? So when you see more of a straight line here, it doesn't necessarily mean that we're not fluctuating, because we are. All right, we're fluctuating. Now, keep in mind what I just said. It usually goes from 2 to 400, right? Well, 2 to 400 in this whole graph would be the same as 6 to 800 right there, right? So you can imagine what it would look like different right there. Okay, it would basically, be way up here and stuff. That's what I'm trying to say. Now, the density up there, again, we talked about that before. They actually went the other direction with this one. They went lower than 1. Okay, when they do that, that's pretty much no density. There's always some density there, but that's extremely low. Okay, so typically when the solar wind speed goes up, the density will go down. Okay, and I've talked about this at length before. When they both go up at the same time, that's when we get hit. And look, it was popcorning up there a little bit at the same time the solar wind speed was, and that's about when that G2 hit. Okay, it hit a little bit before that back here, but that wind speed is what caused this storm. Okay, just letting you guys know. And again, here's the one that shows you. I'm not going to run the graph, but right now we are, as I'm making this video, we're right here. We're right at the peak of this. Okay, so as you can see, this graph doesn't really show what the actual conditions are, because we're seeing stuff up to 800. And the reason why that is because if they were to do that, this graph would not look, kind of smooth. It would be popcorn like the ace I just showed you. Okay, what this is doing is taking like an average and plotting points that way, so this thing is more smooth. So if you guys can understand that. Instead of just taking a data point, entering it into the model like that, they're taking multiple data points, taking an average, and entering it in that way. And that's why it doesn't look like it spikes up as much or down. So if you ever see like a huge way up spike to way down spike, like right next to each other on this graph, either that was a flaw or something crazy is happening. Also, guys, I know it's really interesting. This here's the Northern Lights. Okay, I'm not going to run this graph, but I was asked to talk about this for a minute. What this is, guys, and I'll put it at the end of my videos from now on, this is the Northern Lights prediction. Okay, they're predicting that at this timestamp, this is what the chances of seeing Northern Lights are at your position. Okay, so when we talk about lower latitudes, we're talking about stuff getting closer down towards it, moving towards the equator. It never gets down that far. Typically, it stops around Colorado, kind of here in the middle of the country. I live in Indiana, so I do see them every great once in a while. It's pretty rare. Have to be out in the country, perfect conditions. But this is cool stuff. This is what's cool about it, because people can go out and they take pictures. These are raw photographers. We've all seen them. Most of us have. And don't be fooled. This happens on the South Pole too. Okay, so the Southern Hemisphere gets to see this stuff too. Takes a bit different conditions, but yeah, they do. They see it sometimes. Again, here's that KP level. You can tell that it's elevated. It's not coming down. It showed on all the charts, so it wasn't like cosmic ray stuff. We know it come from that coronal hole. So we'll leave it at that. But we're going to talk about this initial spike. Okay, I'm going to pause for a second. All right, guys, got you back here. This right here, guys, is back on the 28th. Okay, this is SDO. This is 193 angstrom. Okay, this is the bronze view. It's just a different wavelength, and we see different stuff in different wavelengths. I would encourage you guys to go back and watch some of the other videos. I've talked about that at length on multiple other people. And I will explain. I'll continue to explain. Just right now, I want to try to get through this video so it don't take too long. But this is that corona hole that's affecting us right now. This was the remnant of that first one that came through. Okay. and they gave us a little bump up, not a whole big bunch. But what happened last night, guys? Okay, yesterday, when I was saying that it looked like as if this thing had come 24 hours in what they had predicted it. All right. What happened was it was what they call a stealth solar storm. Okay. Stealth meaning it was hidden. All right. We all know what stealth fighters are. They're not meant to be seen. Well, you have stealth CMEs, and I've talked about this just a little bit here on my channel. We have stealth solar flares. We have stealth CMEs. We have stealth solar storms. Basically what they are is they're all of those that are hard to see, and sometimes most people miss them, even the people that are looking for the stuff. Okay, they're hard to see. So when we get those spikes, they're not expecting it. Then they go and they look. Okay, and to be honest with you, I can't. It's hard for me to even catch a stealth CME. I don't know all the particular data points that they go look at to see if that's actually what happened. But that is what happened this time, okay? Basically what happened is that it was right in front of this coronal hole, and we see a lot of those around these coronal holes, okay? Because they are unstable areas, typically. At least they're more active areas around these coronal holes because the surface of the sun's being exposed. Okay, that's what the solar wind is. And I would encourage people to go check out Scott's new technique. He's shown it quite a bit. He was able to develop a technique photography-wise, or with these tools, with overlays and all kinds of different other things, where you can see the charged particles. Okay? Now, what I like to explain here is, we talk about the corona of the sun. And we all know that that's the haze around the edge, right? Well, we oftentimes forget that this is a two-dimensional model, but we're looking at a three-dimensional object. Okay? So, wherever there's not a coronal hole, this haze is right here too. We're looking at it. All right? That's the atmosphere of the sun. We oftentimes forget that. It's easy to forget. I mean, because when you're looking at this, because you're not seeing a hard edge with the corona off the side. Okay, that's what I'm trying to say. But anyway, it was a stealthy little thing that happened right off the western side of this thing. Okay? And when we talk about western side, we're talking as if we're standing on the sun. What we consider, if we're looking out at the earth, they call, basically it's reverse, guys. If we're looking at from the SDO, the western, when they say western limb, they're talking about this side over here. Okay? It's reverse of what you would actually think it would be if you were looking at a map. So that's, I try to explain that to people too, because it confused me for a while also. Yeah. It's hard to believe I was confused. Just kidding. But anyway, I wanted to share that with you guys because that is what actually happened. So when we see these spikes sometimes, if we can't say, hey, there were coronal holes, we can't say that we really can't say that they were cosmic rays, because those are hard to detect also. Not hard to detect, but more of them are coming through right now because of the solar minimum. The sun protects us from those cosmic rays because it generates a shield around the solar system. It actually stretches out, guys. You guys should research that. I've talked about it a little bit, but it actually protects us from a lot of cosmic rays. And when the sun goes into a weakened state, such as a solar minimum, more of that stuff gets through. And because of these cosmic rays, they actually will issue like warnings for people that fly a lot. Because a lot of people don't understand that when you're in those planes, you're up at a higher latitude, or higher altitude, that those cosmic rays are more intense. Okay, so people that are pregnant, people that work in the flight industry, people that fly like 800 hours a year or more, something like that, it definitely, you need to pay attention to that, because you can get sick. And it's true. They've linked it. They actually issue warnings and stuff for that kind of thing. Those that are frequent flyers probably already know this, but those that don't fly don't know that. So when you're up that high, the cosmic rays do affect you more. It's basically radiation, guys. Okay? And we've talked about that before. And I'm going to start showing those radiation graphs in my videos at the end on the model recap thing I do for you guys. But just keep that in mind, okay? But anyway, we had that little stealth thing, and that's why it looked as if it got here too soon, okay? Now, stupid ads. Anyway, yeah. What we're going to do now is we're going to go look at that CME tracker. I'm going to explain something real quick about the CME tracker I was showing you guys, okay? This is planetxnews.org. This is where I go to that CME tracker. Scott's got a bunch of links over here. And check out this article. This actually pertains to, Hurricane Dorian. He done this a couple days ago when they were forecasting this thing to kind of come on like this. It's called a king tidal phenomenon. Guys, go watch that. It's very cool stuff. It really is. Go read that article. He does a lot of good articles over here. See that? He's talking about the rainforest. Here's the article he did on the finding down there on Google Earth about the alien face at the Antarctica. Just bunches of good stuff over there, okay? Just a lot of good information. A lot of good articles. So anyway, I go down here to these links, okay? This is where I go. If you're on your phone, it's about halfway down. If you're on your PC, it's over to the right. Not very far down at all. It's easy to find. Basically, you can go here. So I hit the CME tracker link, and this is what I show you guys, right? Then this is where we were talking about yesterday on my video about that anomaly. Well, it's right there. Okay. Now, if you notice, this is no different than what I showed you yesterday. Okay, they typically do not update this model unless there's a known CME. This is a CME tracker, so they don't feel the need to update this thing unless there's some sort of a CME. So, with that being said, I've seen this thing not get updated for like a month. I'm just saying. So, sometimes it's going to be hard for us to track this thing. Okay? Unless there is an event, unless there is a CME. Now, I would be hard-pressed to think that we're not going to have not even a small CME or discharge within the next couple weeks, because typically we don't go that far in between. Even during a solar minimum, we still get small CMEs, and they do update this thing. So I'm hoping that, that we still get updates on this. Now I'm going to zoom in here a little bit, and I did talk about this a little bit yesterday. You see that little red right there. See that little red right there next to it? I'm sorry I can't stop this. It just doesn't let us. That right there pretty much confirms that this is probably some sort of an object that's out there. I was talking about this with Scott, and, he pointed me to the asteroid belt. There's an asteroid called Vesta. And he gave me a link. I'll leave a link. You guys need to go research it. And there was an awesome comment from one of the subscribers left a comment. They actually went and did some research on that asteroid and what it was made of, which is very conducive to, electromagnetic field, which would make sense that it could be trying to connect to the sun. Okay. Is that what's going on here? I don't know. I'm not thinking that's... I don't know. I just don't know yet, because this thing is moving fast. In 5 to 7 days, it moved over 90 degrees. Vesta is not moving that fast. Okay, it's also in a highly elongated orbit. It almost looks like it comes out of the asteroid belt. I'm not sure if it does or not at all. But it's very, very elongated. I think it said it takes 4 years or something to orbit the sun, I mean. And again, we're talking about the asteroid belt, guys. We're talking about, this right here is Mars. So we're out past that. Basically, we're in between Mars and Jupiter when we're talking about the asteroid belt. That's what we're talking about. Okay? So, I just wanted to point that out. So, unless we have a CME or something, we won't see an update on this. So, if you don't see me talk about this for a minute, that's why. And we just simply won't get any updates. It won't update this model at all. But I'll leave an update, guys, to the models and stuff. But guys, anybody down in Florida or East Coast, stay alert. We are, we still, that solar storm is still ongoing. All right. Actually, I'll take you guys over here real quick before I let you guys out of here. Let's go. This one here, I actually like this one better than the space weather graph I show you guys a lot. I put this at the end on my end of my videos too. It's basically showing you the same stuff, but in a different way. There's the KP, okay, but it shows you other stuff too. It shows you the GOES 14, the GOES 15, which are these different colored lines, and what they're reading. That's what these are showing. It's showing you its readings. Here's the key over here. Okay, this is the electron flux. Basically, it's the amount of electrons that are going on right at that time. And when we see these events, you'll see spikes. Okay, that's what that's showing you. And then again, up here is the X-ray flux. Okay, keep in mind our visible light is very, 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 very small to the whole light spectrum. Okay, just letting you know. What we can see is very, very little. That's why we have to use these tools to look at this. Now here, and this one right here really kind of shows a more elongated look at the KP. Okay, it's showing you the same levels. So in other words, when we get to a 6, that's what they consider a moderate geomagnetic storm. I think if you get to a 7, they consider it like a major. Then obviously it goes up and up and up, right? So whatever they're going to call it is whatever, but we can just put a number on it and it's easier to understand. Then this here is the actual proton flux. Okay, so when we start talking about proton density and all that kind of thing, we look at this, and if there's spikes on this, that's where that stuff's coming from. But anyway, I am going to end the video here, guys. I'll put an update here on the end. And I hope you guys have a good Labor Day weekend, and God bless, Yeshua saves, and you can drink this Kool-Aid. Hey, one more thing, guys. Sorry. I was putting together the music for the models here in just a second, and I thought it was pretty appropriate to use Rock Me Like a Hurricane. Yeah, and Can You Take Me High Enough by the damn Yankees. I thought that was pretty appropriate for what's going on. Hope you guys enjoy it. God bless.
Can't you see I'm in misery? And you know